Pre-AP Calculus, Notes 9.1, Reviewing Right Angle Trig. Consider triangle ABC shown to complete the trig equations. Notice this triangle has a right angle. All of this stuff in here only applies if you have a right triangle. Furthermore, these angles that you see here can only refer to the acute angles. Acute angles between 0 and 90. So angle A and angle B, those are the acute angles. In no context with right angle trig could those angles be dealing with angle C. Doesn't make any sense. So review this part here straight out of geometry. This part here is new, but it's not going to be difficult to make that connection. Sine of an angle, please note, I should make this clear. You always have a trig function followed by an angle. That will always equal a ratio of two sides. A side over a side. Always. There's no other way to write this. Trig function always has an angle to the right of it. It's always equal to some side over some side. Trig ratio are the words sine, cosine, and tangent, and these new ones that we'll discuss in a moment. Sine of an angle is defined as the leg opposite the angle you're using divided by the hypotenuse. Cosine of an angle is defined as the leg adjacent to the angle you're referring to over the hypotenuse. And tangent of an angle, by the way, these angles that you see here are thetas, so Greek letters, is the opposite leg over the adjacent leg. Easy way to remember that is the acronym SO, CA, TO, A. Sine, opposite leg, hypotenuse. Cosine, adjacent leg, hypotenuse. Tangent, opposite leg, adjacent leg. So in this picture, it says find the ratio of sine of angle A. So if we're referring to angle A, sine is always the opposite leg, which let me label this as A, B, C. A naming convention that we have, opposite an angle is the same letter but lowercase. That's true in each of these. So going back to sine of angle A, it is the opposite leg, which is A, over the hypotenuse, which is C. Cosine of angle A. Cosine is the adjacent leg. There are two adjacent sides, but only one of those are a leg. The adjacent leg is side B over the hypotenuse, which is C. Tangent of angle A is the opposite leg over the adjacent leg. So that's going to be A over B. Come down here and look at sine of angle B. You start with the angle that you're referring to. Sine of angle B is the opposite leg, which is B, over the hypotenuse, which is C. Cosine of angle B is the adjacent leg over the hypotenuse, so that's A over C. Tangent of angle B is the opposite leg over the adjacent leg, so that's B over A. So what about these new trig functions? Secant of an angle, which is abbreviated SEC, is defined as the reciprocal of cosine. So if we look here, here's cosine. Cosine is the adjacent leg over hypotenuse, therefore secant of the same angle is the hypotenuse over adjacent leg, the reciprocal. So this is C over B. Just take the fraction and reciprocate it. The cosecant of angle theta, abbreviated CSC, is defined as the reciprocal of sine of theta. So if sine of theta is the opposite leg over hypotenuse, then cosecant of theta is the hypotenuse over the opposite leg. Let's reciprocate it. Cotangent of an angle, abbreviated COT, is defined as the reciprocal of tangent. So here's tangent, which is A over B. Therefore, cotangent is B over A. 6 trig functions we're going to be dealing with. Reciprocal of sine is cosecant. So this is going to be C over B. Reciprocal of cosine is secant. So that's going to be C over A. Reciprocal of tangent is cotangent. So it's going to be A over B. couple more things before I get off of this topic. Just remind you that SIN is short for sine, which is short for sinus. Sinus means opening. The word sine comes from opening. I can explain that more in class if you'd like. COS stands for cosine, which stands for complementary sine. Now, why is it called complementary sine? This question is referring to that. What do you notice about the values of sine and cosine ratios for two complementary angles? So if I take sine of angle A, notice that B is the complement of angle A. Complement means two angles have to be 90. It will always equal the complementary sine of the complementary angle. So what that means is sine of A, we said, is A over C. Cosine of B, also A over C. Because they are complementary angles, it will give you the same answer. So a more general version of this, sine of any acute angle will equal cosine of the complement of that angle. Always equal to each other. I think it was less than 9.2 in geometry last year that we learned that. And then lastly is TAN is pronounced tangent. And the reason it's called that for this specific thing is a little more complicated that I'm not going to go into. All right, that concludes the review of the three main trig functions and the introduction of their reciprocal trig functions. You need to memorize that sine and cosecant are reciprocals. Cosine and secant are reciprocals, and tangent and cotangent are reciprocals. Tangent and cotangent are easy. The other ones are not easy to remember. I remember cosine and secant because if you take the first two letter, the first and last letter of the abbreviations, they're backwards of each other. And then I remember sine and cosecant as the two that are left over. That concludes video 2 of 7 for this section.